Hey, welcome to Math 212, Math for Elementary School Teachers at Blue Mountain Community College. I'm Gary Parker. Welcome, your teacher this quarter. So what's this course about? The theme of this class is fractions, all things fractions. So quick look at fractions. Think about numbers. Usually the easiest thing to do is add, but with fractions, that's a bit complicated. To add two fractions here, I need a common denominator. So 6 times 10 is 60, so I thought 60 would be a good denominator. And 1/6 would be 10/60ths, and 3/10 would be 18/60ths. Because if I multiply top and bottom by 6, 6 times 3 is 18, 6 times 10 is 60. Common denominator is 60, 10 and 18 is 28, so I get 28/60ths. But we learned that fractions ought to be reduced. And so reducing 28/60ths, I noticed that they're both even. So I could divide top and bottom by 2, which gives me 14/30ths, which, hey, they're both even. I can reduce again and get 7/15ths. Now, let's see. 7 doesn't go into 15. 15 is 3 times 5. 3 doesn't go into 7, neither does 5. So I think I'm done reducing. So reducing is not trivial. It's a bit of work. Deciding on a denominator and then adjusting the fractions, that's a lot of work. Now, it turns out there's an idea called lowest common denominator we're taught with fractions. 60 isn't the lowest common denominator. It's just a common denominator. Turns out 30 is a smaller denominator, and it's the smallest possible denominator that would work. So let's see, 6 goes into 35 times. 5 times 1 is 5. So 1/6 is 5/30ths. 10 goes into 33 times. 3 times 3 is 9. So 3/10 is 9/30ths. With a common denominator of 30, 5 plus 9 is 14, which we know from above reduces to 7/15ths. So why couldn't we use 15 as the denominator? Well, 6 doesn't go into 15, and neither does 10. So even though we had the smallest possible denominator to use, we still had to reduce after. Now, the idea of finding a lowest common denominator is hard work. Reducing is hard work. Those two activities are part of an area of math called number theory. Number theory is related to factors and multiples and prime numbers and composite numbers. So we're going to start off studying number theory so we can better work with fractions. So part 1 of the course is going to be playing with number theory. Part 2 of the course is learning or relearning why we do fractions the way we do. Could we do them another way? How do we model them physically? And then from there, we're going to move on to decimals. 3/10 is the proper way to read this thing right here. We often say 0.3 or 0.3. That's slang. Proper way to read it, identify the decimal value, decimal place value, and then say it as a fraction. So 3/10 is a fraction and a decimal. These things are called decimal fractions. So decimals is the next big topic in this course. Following that, we'll play with ratios, which is a view of fractions a little bit different than a part of a whole. Like in general, for classes I teach for future teachers, there's about 3 women for every 10 men. I wish. Not to be sexist or anything, but it'd be nice to have more men in an elementary school classroom. Typically, that's flipped. There's usually about 10 women for every 3 men. And usually it's less than that, too. Proportions are when we take a fraction, like when I make pizza dough, I use about 1 cup of water for every 3 cups of flour. I want to use 10 cups of flour. How much water should I use? That's a proportion when we relate to fractions and we want them to be equal. Probability. There's a 50% chance of snow at 3 p.m. today. 50% is equal to 5/10, which is equal to 1/2. So fractions, decimals, percents in terms of probability is another big topic. So I would say topic number 4 is ratios and proportions. Together, they work together very well. And topic number 5 is probability. And that's going to take us all quarter. So I look forward to working with you on this fun stuff this quarter. Good luck, stay in touch, and do good math. Adios.